Atoms are generally not found all by themselves as single atoms. They're usually found in molecules and ions. In fact, only the noble gases are generally found as single atoms. All other species that are stable will be found as molecules or ions. So molecules are two or more atoms bonded together. And in some cases, atoms just bond to themselves in pairs, and those are known as diatomic molecules. And there are several that you should be aware of: hydrogen, nitrogen, oxygen, and all of the halogens: F2, Cl2, Br2, I2. Those are ones that are stable and naturally occurring in twos with each bonded to each other. Okay, and there's different ways we can represent molecules. I'm going to show you a few. One of them is the most common, which is known as the molecular formula. One example would be F2. Another example, which is not two atoms of the same, would be H2S. Okay, so those are the molecular formulas, and the most familiar, probably. We also can do a structural formula, which shows how they are bonded together with a line used for the bonding. So those are the structural formulas for those two examples I've given. We can also use three-dimensional models, okay, in which case we use some kind of a sphere. And this is obviously not three-dimensional, but we can use spheres. We also, when we use spheres, we tend to show the shape of the molecule. And then finally, the empirical formula is one that is similar to the molecular formula, but it shows the same formula using the smallest ratio of whole numbers as subscripts. Okay, for example, F2 is just two F's, so we just say F. It's just F. H2S would also stay H2S. Okay, but the general rule is that you use smallest whole number ratio from the molecular formula. I think that we need more examples here. So let's compare molecular formulas and empirical formulas for these four species. Remember, it's the ratio of the lowest whole number ratio from the molecular formula. Okay, so C3H9, the lowest whole number ratio of 3 to 9 is 1 to 3. So the empirical formula would be C1H3. And of course we don't write a 1 if it's a 1 subscript. So that's the empirical formula. The actual formula is the molecular formula, but empirical shows the ratio of the different elements. N2O, it's 2 to 1. You can't reduce that at all. It's just the empirical formula is exactly the same as the molecular, like it was for H2S. H2O2, it's 2 to 2. The lowest whole number ratio would be 1 to 1. So its empirical formula is HO. And P4O10, you should be able to write that one down. The ratio is 4 to 10. Both those numbers are divisible by 2. So the lowest ratio would be P2O5. Okay, molecules will not be charged, but there are also ions, which are charged species, and they are atoms or groups of atoms which are charged. So they have a net charge. This charge can be positive or it can be negative. And as you know, the positive charge comes from the protons in an atom. the negative charge comes from the electrons. So in order to have a net charge, you will have to have the case where the number of protons is not equal to the number of electrons, because if they were equal, you would have no net charge. All right, let's do some examples. If you look at the periodic table at fluorine, you'll see that it is atomic number 9, which means it has 9 protons. And if it has 9 electrons, we give it the symbol F. Okay, but what if something has 9 protons and 10 electrons? Then it'll have one more negative charge than positive charge, so it will be F minus. It'll be negatively charged overall. Another example, 3 protons. If you look at the periodic table, that's lithium, and if we have 3 electrons, that's neutral lithium. We don't write a charge. But what if we have 3 protons and 2 electrons? Then we removed 1 electron, so it's a net positive charge, and it would be Li+. Okay, when they are negatively charged, we call them anions. And when they're positive charged, we call them cations. All right, so try this. Which symbol do you use for 8 protons and 10 electrons? If you look at the periodic table, 8 is oxygen. Okay, so you know the symbol is O, but what about the charge? They aren't equal. There's more electrons than protons by 2, so the charge is 2 minus. How about part B? How many protons and electrons are in Al3+? Again, to get the number of protons, look at the periodic table, atomic number 13. So it's got to have 13 protons or it would not be aluminum. And if it's 3+, that means there are fewer electrons than protons. We can't change the number of protons and still call it aluminum, but we can change the number of electrons. So we would say there are 10 electrons. One thing that's really important for you to get out of this, though, is that we can predict the charges for main group ions. Okay, main group ions are predictable. Okay, so how do you do that? You look at the periodic table, you look how far away the main group is from the noble gases. Okay, the noble gases are here. And remember that the periodic table basically wraps around so that when you are in group 1A, you are actually just 1 away from the noble gases. So the anions will be in the nonmetals, and if you're 1 away from the noble gases, it will have a -1 charge. If you're 2 away, it'll be -2, and if you're 3 away, it'll be -3. So these are the anions, and they will only be in the non-metals. And if you look at the metals, they will always be cations. This is, group 1A is 1 away from the noble gases, so it's 1 positive. Next door to that is 2 positive. And jumping across the transition metals, you then get 3+ over on group 3. So these are the cations. Okay, so now you can look at where a main group element is in the periodic table and figure out what its charge will be. Okay, so we're going to practice that in this next part. Try this, which ions will be formed, and then also are they cation or anion. So for example, calcium. You know calcium is in group 2, so it must be a 2+ charge. And 2+ is a cation. Okay, whenever it's positive, it's a cation. So try the rest, and then check your answers. B, S, sulfur, is in the same group as oxygen, so it is a 2- group, and anything minus is an anion. Potassium is in group 1A, it'll be K+, positive is a cation. Bromine is a halogen, it's in the 1- group, and so it's minus, so it's an anion. All right, then once we have the ions themselves figured out, we can put them together to make compounds by making sure the charges of the ions cancel each other. Okay, how do we do that? So now you know, you should be able to now predict that sodium will be plus because it's in group 1, and chlorine will be minus because it's in group 7. Okay, when you put them together, the charges have to cancel each other to make a neutral compound. A 1 plus and 1 minus will directly cancel with each other, and the compound will be NaCl. Okay, but those are the two with the same magnitude of charge, 1 minus, 1 plus, but they won't always be the same. Magnesium is 2 plus, chlorine is only 1 minus. So you're going to need 2 chlorines to balance out the charge of the magnesium. One way to think of that is to take the magnitude of the charge and crisscross it. Okay, so you think of the 2 plus as just being 2, and the 1 minus as just being 1, and the 1 becomes the subscript for magnesium, the 2 becomes a subscript for chlorine. So that compound would be MgCl2, which is the same as saying you need 2 negatives to balance 2 positive. Okay, trying it with iron 3 plus and chloride. Crisscross the 1 to give an Fe. Crisscross the 3 to give Cl3. All right, but we do need to also use the lowest ratio. I'll show you that here. If we crisscross Mg2 plus and O2 minus, our compound would be Mg2O2, but we actually always reduce it to the lowest ratio. Kind of like an empirical formula, but it's a little bit different. Anyway, we don't call it Mg2O2. Instead, it becomes MgO, just a 1-to-1 ratio. All right, so from that, you should be able to answer these next questions. Which of these 4 compounds do not exist? Okay, in order to answer that, look at the charges and see if they cancel. So stop the video and do that for yourself. Also, work on part B and stop the video before you go on and see if you can do it. Okay, calcium and potassium. What is the charge on a calcium? Look at the group where it is. It's group 2. It'd be calcium 2 plus. Potassium is K plus. You're never going to get a compound that's just a plus with a plus. That will not neutralize. You need a plus and a minus, so that's not going to work. Calcium we know is 2 plus. Bromide is a minus because it's in group 7, 1 away from the noble gas, and it's a nonmetal, so it's negative. So 2 bromines and 1 calcium will be a compound. So that one's okay. That one does exist. Ks. Okay, potassium we said was plus. Sulfur we said was 2 minus. Put those together, it will not be a 1-to-1 ratio. You'd crisscross them. So that one also does not exist. And instead you would get K2S, crisscross the 2 and the 1, and you would get this. Okay, so this one's okay. Okay, so do not exist would be the first one and the third one. All right, form an ionic compound from these species. Na and S. Na is group 1. So it's a cation with a 1 magnitude. Sulfur is a non-metal, so it's an anion, and it's 2 away from noble gas, so it's 2 minus. Crisscross those. You'll get Na2S. Aluminum and oxygen. Aluminum is group 3, and it's a metal, so it's group 3, so it's a 3 plus. O is a 2 minus. If you crisscross those, you get Al2 from the oxygen and O3. And you can't further reduce that, so that is the formula.